Let's continue with the third concept, that is called molarity. So molarity we are going to define as the number of moles of a solute which is going to be dissolved in 1 dm cube. 1 dm cube is nothing but 1 liter of the solution. So here capital M is the denoted form of the molarity, that is capital M. So this is in definition form. We are going to write in the formula, that is number of moles of a solute, that is same of the definition, number of moles of the solute divided by volume of the solution in liter. Volume of the solution in liter. So let us take a very simple example. If I take the sugar solution, that is called sugar solution, which is going to be dissolved in the water, right? So the total solution is containing 2 m. That is total solution is containing 2 m. So how can you tell according to molarity? So that is nothing but 2 moles of an sugar solution, 2 moles of a sugar which is going to dissolve in 1 liter. Like this we are going to calculate here. So let's see one problem based on this molarity, that is 40 gram of NaOH dissolved in 250 ml, find its molarity. And one more term we should know, that moles. So what is the moles formula? Moles is nothing but mass of a substance, mass divided by molar mass or molecular mass, both are same, molecular mass. So first we should know the moles, then only we are going to calculate, because as given the number of moles means first we should find out the number of moles, then we are going to take it in 1 liter solution. So let's see the formula. 40 gram of NaOH is dissolved in 250 ml, find its molarity. Right? It has given in a gram, but what we required according to our formula, moles has given. First we should find out the moles. Moles of NaOH, that is equal to, what is the formula? Mass. Mass as given, how much? 40 gram divided by, what is its molecular mass? We should find out the molecular mass. So sodium atomic mass is 23 plus hydrogen 1, that becomes 24 plus oxygen, that is 16. So total how much? It contains the 40 gram per mole. So how much I got here? I am cancelling gram, that is nothing but 40 division, so that is 1 mole. 1 mole I got. So now I substitute in 1 mole of the solute we got, and volume of the solution in liter has given the 250 ml, but out of 1 liter. So that you should write. Therefore, molarity, that is M of an NaOH, molarity of an NaOH is equal to number of moles of the solute, that is we got 1 mole divided by volume of solution in liter. It has given 250, but it is in 1 liter. So 1 liter is nothing but 1000 ml, right? 1000 ml. So after this calculation, what we are going to get values? I got 1 mole, so I am going to write as 1 mole divided by 250 by 1000 ml. That is in terms of the liter only. So that is called 1 by 4, right? 250 by 1000 is 1 by 4. After the calculation, I am going to get, it is in terms of liter, 1 by 4 liter. Okay. So after this calculation, now it becomes 4 moles per liter. 4 moles per liter. So simply I am going to write as 4m, because moles per liter. This is moles per liter. So I got the value as 4 moles per liter. So simply I am going to write as 4m. So this is the way of finding out the molarity of the given substance. So that is the last one. We are going to discuss about the molality. You should not confuse with molarity and molality. So that is what molarity is nothing but capital M denotation. Here it is a small m, molality. Right? So both are same, but only some difference will be there. So molality is nothing but number of moles of a solute which is going to be dissolved in 1 kg of solvent, whereas molarity is 1 dm cube of the solution, right? So here this is 1 kg of the solvent, and its denotation is small letter m. So that is the formula is number of moles of a solute divided by mass of solvent in 1 kg. So that is called molality. Okay. So what is it? First you should think difference between the molarity and molality. That is what is the unit of the molarity? Molarity of that unit is moles per liter. That is called molarity. And here moles per kg. Moles per kg, that is nothing but your molarity. Whereas molarity is nothing but moles per liter. That is called molarity. So only slight difference between there. So let's solve the problem. 20 gram of NaOH which is going to be dissolved in 100 gram. So find its molality. Same thing of the molarity. First we should find out the molars because it has given in the gram, right? So first what we are going to take? First we should take the moles. In terms of moles, that is nothing but mass of a substance, that is 20 gram divided by what is its molecular mass or molar mass. So that is nothing but NaOH, that is 40 gram per mole. After this calculation, what we are going to get here? We are going to get 0.5 mole, right? 0.5 mole, because 20 1 ja 22 ja, that is 1 by 2 is nothing but 0.5 mole. So next, what he is going to ask, we should find out the number of moles of solute, right? Number of moles of solute is 0.5. So we should find out the molality of the NaOH, that is equal to 0.5 mole divided by mass of solvent in 1 kg. So he has given the 100 gram, right? So I place as it is, and it is 1 kg is nothing but 1000 gram, right? 1000 gram. So why I have placed here? So we should think, because this is comes under 80 gram, not a 100 gram. Why? You should see the question. Out of 100 gram, this is called 100 gram of solution. In that 100 gram of solution, 20 gram of NaOH. 20 gram of NaOH, that is nothing but solute which is going to dissolve. So out of 100 gram, 20 gram of solute is there. Then what is the remaining? That is 100 minus 20 is nothing but 80 gram. So that I have placed here, right? So 80 gram divided by 1000 gram, because out of 100, 20 gram of NaOH is dissolved. Remaining 100 minus 20 is nothing but 80 gram. So after this calculation, how we are going to get it? So 0.5 into 1000 divided by 80. So this 0 is cancelled. So 0.5 into 100 is nothing but 50 divided by 8. 50 divided by 8 comes under. So its around value will be 6.3 or 4. I write 3. 6.3 molarity. Why? Because molarity, it is a divided by the moles per kg. It is in form of moles per kg, right? 6.3 moles per kg will be there. So instead of moles per kg, I will write molarity. So answer is 6.3 molarity. Let us discuss with the topic called parts per million. Parts per million, right? So let's see the definition of this one. Parts per million. That is a ratio of the number of the parts of the component to the total number of parts of the all components of the solution multiplied by 10 raised to 6. So that is in the definition form. This is in the formula, and this parts per million can be denoted as ppm. That is called ppm. And also same parts per 1000 also will be there. 1000 means you are going to multiply with 1000. That is 10 power 3. Due to here billion, you are going to multiply with 10 power 6. Only difference is this one only. So this is called parts per million. So let's see one simple example for this one. And you know this parts per million, when you are going to use this one? When you are going to use this one means, so this concept is only applied when the quantities has given very minute, that is called very trace quantities. Let's see the example. The example has been asked that 0.0005 gram of NaCl dissolved in 100 ml of water. Then what is the parts per million? That is, I told that only it is in trace quantity as given, then only we are going to find out in terms of the parts per million, right? So when it is in the minute quantities, right? Let's apply the formula here. Parts per million is equal to number of parts of the component divided by total number of parts of all components into 10 raised to 6. That is nothing but, so what has got 0.00005 gram divided by total 100 ml, right? 100 into 10 power 6. You should convert into parts per million, right? Very simple calculation. So 10 power 2, 100 is nothing but also 10 power 2, right? 10 power 2, and in the numerator 10 power 6. So 6 plus 2 is 10 power 4. 0.005 into 10 power 4. Because of the laws of the indices, 6 minus 2, that is 10 power 4. When it has this 100 has 10 power 2 also, right? So remaining, so you know the significant figures. So when you apply this 10 raised to 4 here, so 1, 2, 3, 4, that is 5 ppm. The answer will be 5 ppm. So like this, parts per million is going to use only when the solution has given only in the trace quantities. We have already seen four important parameters which are going to be present in the concentration of the solutions or measuring concentration of the solutions, that is mole fraction, molarity, modality and mass percentage, and also I have included that is parts per million also, and this one is normality. Normality is also very important parameter which you are going to find out in laboratory. That is also very important, this concept. So let's see the definition of this normality. Normality, it says that number of gram equivalent of solute which are going to be present in 1 liter solution or 1 dm cube of the solution. So let's see the formula, that is N is equal to number of equivalent weight of number of equivalent of the solute divided by volume of the solution. So and the normality is going to be designed as capital N. And we know this, what is this equivalent of the solute? That is equivalent of solute is equal to mass per equivalent mass. In the question mass will be given, but we have to find out this equivalent mass by using this formula. Equivalent mass is equal to molecular mass divided by X. So if we know these rules, we are going to calculate very easiest problems. Okay, that I have asked. So this, if 0.98 gram of H2SO4 are present in 500 ml of solution, find its normality. First we should write the normality formula, that is normality is equal to, this is what indication, normality is decided as the capital letter N. Normality is equal to number of equivalent of solute, number of equivalent of solute. What is the number of equivalent solute? That is nothing but mass by equivalent mass. That you should write mass divided by equivalent mass. That is equivalent mass divided by volume of the solution in liter. Volume of the solution, volume has given 500 ml, right? So that you should write the volume. First you should write mass. Mass has given, that is 0.98 divided by equivalent mass. How to find out the equivalent mass? Equivalent mass is equal to molecular mass divided by X. Here has given the compound that is called H2SO4. H2SO4 molecular formula is hydrogen, that is 2, right? Sulfur 32. So 32 plus 2, 34. Right, I will write 2 plus 32 plus 16 4 the 64. So when you add these one, that it becomes around 98. And this 32 plus 34, 34 plus 64, that becomes 98. And X, what is this X? X is nothing but H plus ions. Number of H plus ions. Number of H plus ions. How many will be there in H2SO4? That is 2 hydrogen plus will be there. That you should divide by 2. So 98 by 2, that becomes 49. That you should write here 49. 4 divided by volume of the solution. Volume has given, that is 500 ml out of 1 liter. That is 500 ml divided by 1000 ml. So how we are going to calculate this one? So very simplified manner. 0.98 divided by 49. How we are going to calculate? So I am going to remove this one. Then it becomes 98, because when 20 will comes, that becomes 98 divided by 4900, right? 98 divided by 4900 divided by 500 divided by 1000. So after this calculation, we are going to get as, it is a 2 by 1, I think. I will write this unit as a 0.98 divided by 49. I am going to write as a 2 by 1. How? So that is when after remove this decimal point, now it becomes 98 divided by 4900. So when you calculate this one, then it becomes 2 by 1. 49 1 ja, 49 2 ja, and these 2 zeros and these 2 zeros will be cancelled. That I have written 2 by 1, and remaining will be 50 will be there, because these 2 zeros and 2 zeros will be cancelled out. So this is, and this 0 and this 0, that is becomes 50. So when after this reciprocal, now it becomes 1 by 50. 1 by 50. So what happens? 2 1 ja, 2 25. That becomes 1 by 25. You are going to get as 0.04 normality. So like this we are going to find out once again. So when this will be given 0.98, how we got this 0.98? Has given the mass. And what is the equivalent mass? Equivalent mass we are going to find out by this formula. Molecular mass divided by X. Molecular mass of this H2SO4 is 2 hydrogen 2 plus sulfur 32 and oxygen 16 atomic mass. So 64 is the 64. When you add this, then it becomes 98. And X is nothing but number of hydrogen plus ions in this compound. That is 2 hydrogen plus divided by 2. Then it becomes 49. I have written 49 divided by 500 divided by 1000. So it is a very simplified calculation. If you know the significant figures, now it becomes 98, right? 98 divided by 4900. It becomes 98 divided by 4900 divided by 500 divided by 1000. This 20 and 20 will be cancelled, and 49 1 ja 49 2 ja. That is what 2 by 1 into 1 10 divided by 500 will be there. This 0 will be cancelled. That is 50 by 1. After the reciprocal, then it becomes 1 by 50. 2 1 ja 2 25 ja. So 1 by 25 is nothing but 0.04 and that is normality. So like this we are going to find out the concentration in the solution, I mean reactions in the solutions.